Okay. So do we have a lot to go through? Should I just cruise through this stuff?
Sure, yeah.
Okay. So for the sake of time and speed, I'm going to just cruise through this and show you how to do it. You can watch the video again later. We're going to make that red and we'll make this blue. That's how I like to do it. Find f of g of x. So f of g of x means I'm taking the red function and I'm plugging the blue function into it. That's f of g of x. So what does that mean? That means I'm starting by writing the red function, but I'm not writing x. I'm leaving that blank, and then I'm plugging in the blue function, which is x squared minus 1, into it, and then I'm simplifying that. Now, you could just leave it like that. You technically are done, because they didn't say anywhere, write it in standard form or general form. They didn't say anything. So you literally are done. You can just be done. Unless the teacher, because it takes time and you can make mistakes if you do more. Okay.
It says on the Math Excel to simplify it.
Dang it. Okay. So it didn't say on here, but if it says to do that, then you're going to have to make sure that you multiply this out, right? So this is going to be, remember, it's x squared minus 1 times x squared minus 1, which is x to the 4th minus x squared plus 1, which is x to the 4th minus 2x squared plus 1. And then you still have the plus 2 on the end of all these. So that's x to the 4th minus, actually, I can simplify, I can add these together here and just say like that. There's your answer. Got it?
Mm-hmm.
So the part B, I'll do part B now. For part B, I'm doing g of f of x. So now I'm plugging f of x into g of x. So I will start by writing my g of x, but instead of writing the x, I leave a space, just like I did for the other one, and I plug in the red function f of x into g of x. Got it? And when I multiply this one out, same thing as before, I'm going to do well, I'll just go ahead and do it. X squared plus 2 times x squared plus 2 minus 1. So these, when they FOIL out, is going to be x to the 4th plus 2x squared plus 2x squared plus 4 minus 1, which is x to the 4th plus 4x squared plus 3. There's your answer. Now, to find these things, since you already went through all the work, you know what you can just do with this 4? Remember, this is your f of g of x. So what's f of g of 4?
Oh, you could just plug 4 in for x?
Yeah, you just plug 4 in because you already did all the work, right? Why do more work if you don't need to? And same with this one. This is your g of f of x. So g of f of 4 is just equal to 4 to the 4th plus 4 times 4 squared plus 3. I'm just plugging 4 in to all of those things. I didn't color code it, but here, see how I'm just plugging that 4 in there?
Yeah.
See, I'm just plugging that 4 in there. So 4 to the 4th, what's 4 to the 4th equal? Let's see.
According to my calculator, 256.
256, that sounds about right. 256, so this is also 256 over here. And then 4 squared is 16, and times 2 is 32, so minus 32 plus 3. So, and this over here is 4 times 4 is 16, times 4 is 64, plus 3. Did I do that right? 4 cubed is 64, yep. And just simplify it. So this equals what? That's minus 29, 30, 225, is it? I'll let you punch those in your calculator. Oh yeah, 227, sounds right. And what's this one on the right?
323.
There you go. There are your answers. Next page. This says that transformations x squared of the following function. All right, so this first, so what we're doing here is, I'll go ahead and write them in. We're transforming your original function. I'll do this in yellow, which is x squared. And remember what x squared does. Look over to the graph at the right. it's going to go starting at 0, 0, it goes over 1 up 1, both left and right, over 2 up 4, both left and right, over 3 up 9, both left and right.
Yeah.
Got it? So there's my graph. There's my parabola, my base function. I'm being kind of careful with it. And so what this thing does to it is several things. It's going to, first of all, it's going to flip it when it's on the outside. Where does it flip it? Up or sideways or up and down?
I can never remember. I always mess that one up.
Well, think about what negative x squared does. What's negative x squared? That's an upside down parabola, right? You remember that?
Oh, yeah.
So it flips it upside down, but the 3 also stretches it. So instead of it being over 1 down 1, it's going to be over 1 down 1 times 3, which is down 3 on both sides. You follow how I'm thinking through that?
Yeah.
And instead of over 2 down 4, it's 4 times 3, which is 12. So it'd be all the way down here, over 4 on both sides. So it stretches it. That's what that's doing.
Yeah.
It's flipped and it's stretched, vertically stretched. And then, but I'm not going to draw those in because what else does this do? What else do the 5 here, the +5 and the -4, what do those do?
Oh, the 5 is going to move it to the left 5, and the 4 is going to move it down.
Good. So I would normally go left 5 and down 4. So my new point is going to be right here at -5, -4. That is your vertex. -5, -4. There's my vertex. And now I'm going to do that same thing with those points. Now I'm going to flip it and I'm going to put the stretch onto it. So I'm going to go right 1 and down. Normally it would be right 1 and down 1, but now it's multiplied by 3. So it's right 1 and down 1, 2, 3, right there. So it's at -7. And then remember that you've got a vertical, or you've got a line of symmetry that runs right through the vertex. I'll draw it in. So you don't even have to worry. You can just basically go right on the other side of that to find the other point. So your graph is going to look like this. And to be sure you did it right, find out what this point is right here. That point is -4. This point is -4, comma, -7, right? And just plug it in and make sure that worked. -4. What's -4 plus 5?
1.
What's 1 squared?
1.
What's 1 times -3?
-3.
What's -3 plus -4?
-9. Or -7.
-7. Look at that, it worked. -4, -7. So I do that just to check. I do that, and I use that method to check. Okay, got it?
Yes.
All right, let's try this one.
Wait, let me
It
make
says
sure
use transfer.
let me
Say
make
again?
sure the numbers are the same.
Oh, okay.
Because sometimes, you know, Math Excel does that dumb thing where like
Right.
changes the numbers.
Dumb Math Excel.
Is this, wait, that's the wrong problem. I have like 5 Math Excels open right now. Okay, wait. It changed it. It's no longer that. Okay.
Okay, so this your normal graph, your base graph, again, I'll do this in yellow. Your base graph starts at 0, 0. And it goes over 1 up 1 to the right, and over 2 or over 1 to the left, down 1 to the left, because it's a cubic. So if I go over 2, 2 cubed is 8. So if I go over 2, I go up 2 cubed, which is 8. If I go left 2, I go down 2, which is -8. So that's why your graph looks like this. Okay, but these things change it. That moves it where?
Oh, that moves it left 7.
Good. And what does this move it?
Up 2.
Up 2. So left 7, up 2. Every point moves left 7, up 2. Or you could just put that point there and then go over 1, up 1, over left 1, down 1, over 2, up 8. So that would be right up at the top, right? And over 2, down 8. So that'd be, I think, right there. Get how that works?
Mm-hmm.
And there's your graph.
Easy.
Make sure your points look decent in there as well.
Mm-hmm.
Okay, that one was pretty easy, wasn't it?
Yeah.
Next one.
Mm-hmm.
It says evaluate the piecewise function at the given values of the independent variable. So they want you to evaluate it at -1, at 0, and at 1. Well, the trick is to make sure you're plugging them into the right equation. So notice what the domain restrictions are saying. You use this equation if x is less than 0.
Yeah.
So that would be, I'll erase these things. Which ones would that be? Which ones of these three, A, B, and C, is x less than 0?
A.
Just A. So that's the only one that I'm using for that one. And it tells you to use for anything when x is greater than or equal to 0 to use this equation, and that's B and C, right?
Yeah.
So just make sure you're plugging it into the right thing.
Mm-hmm.
So I'm plugging 1 in to that blue equation. I'm plugging 0 into the blue equation, and I'm plugging -1 into the red equation. Got it?
Yeah.
So this is -3 plus 3, which is 0. So there's your answer.
Mm-hmm.
This is 0 plus 7, which is 7. So there's your answer. And this is 2 plus 7, which is 9. So there's your answer. Those are your 3 answers.
Nice.
Make sense how we did that?
Mm-hmm. Those are pretty easy.
Yeah, not too bad once you understand what they're asking.
Yeah.
So this thing is asking you to find f of g of -5. Now, in the first problem I did, they asked me what f of g of x was. So I didn't waste, but I spent all that time finding that formula. So I said, well, I might as well plug in these numbers into that formula. But if they're not asking you to find f of g of x, if they just want you to find f of g of -5, then just do this first, and then whatever you get, plug it into this.
Mm-hmm.
That makes sense? So for this one, I'm actually going to write it like this. And now I'm going to start figuring these things out. G of -5. Let me color code because I feel like that's been working pretty well. So f of g, that's g of, and they actually want me to find it of -5. So if this is that's my blue function, the red function is g of x. Let's find out what g of -5 is. G of -5 is -5 minus 6. And what's -5 minus 6?
-11.
Good. So now I'm going to find f of -11, right? Because that's what g of 5 is. So I'm finding f of -11, and that equals -11 squared, which is positive 121. So there's your answer. So don't waste your time by trying to find the actual function itself in terms of x. Don't waste your time doing that. You don't need to do that.
Okay.
That makes sense?
Mm-hmm.
Awesome. You have some more questions for me?
I can get some.
Do it. Let's go. We cruise through those ones.
Yeah. All right. I'll just write it on the page. So it's h of x negative 5x minus 15. That's what you're looking for. I don't know what this means when there's 3 values in an inequality. Like in the middle one?
Yeah, all that means is when x is between -4 and 5.
Oh, okay.
So what we would do here is we would draw our xy plane, and we've got the numbers -4 over here, and we've got 5 over here. So there's going to be 3 sections of our graph. Everything left of this is going to be that line. Everything between here is going to be that line, and everything to the right of this is going to be that line.
Mm-hmm.
Now, they probably didn't ask you to graph it, did they?
No.
So we don't really need to graph it, but I'll show you that it's really not that big of a deal to graph it. Like what I would literally do is I would take, I'll color coordinate these, of course. I would take this -4 and plug it in for x and find out what that point is. -4 times -5 is +20. 20 minus 15 is 5. So -4, 5 is your point. And it's an open circle. -4, 5.
Okay.
And then the I'm gonna write that over here, -4, 5, because I'm actually gonna graph the equation. What's the slope of this equation?
-5.
Good.
Next.
Which means it's gonna go right 5. I'm sorry, so rise over run. Down 5 over 1.
Mm-hmm.
Right? Down 5 over 1. So this line is going to be like this. But is it going to the right of the dot or to the left of the dot? What's this telling
To
you?
the right of the dot.
Look at it. It's saying x is what?
Oh, less than. So to the left.
Yeah. So that's going to the left of the dot. So it's actually only going this way. There's my slope of 5 right there. You understand that?
Yeah.
So this middle region, what is the equation y equals 5? What kind of line is the equation y equals 5?
Straight line.
All lines are straight. Do you mean horizontal or vertical?
Oh, yeah. Horizontal.
Good. It's a horizontal line at 5. So that's this line right here. So and notice that it's got an open circle on the right, and it's got what kind of circle on the left? At -4, what kind of circle is it?
Close?
Yeah, because of the equal to part.
Oh,
See
yeah.
the equal to part. So it happens to be on that same dot. So I'm just going to fill in that dot. How nice.
Nice.
They actually meet up. That doesn't always happen, but it can happen. And then what's this last section here, which shall be green? What kind of point is that, or what kind of line is that going to be? Sorry, I just said it's a line.
It has
what's
a
the
slope of 1.
It does have a slope of 1. And where's the starting point? Plug this 5 into it. Tell me where it's going to start. It's going to start at 5, what?
I don't know.
Plug 5 into the equation.
Plug 5 in for x?
Yeah, because isn't that what we're saying here?
9?
Yeah, it's starting at 5, 9.
Oh, that's suspiciously easy. That's why I was confused.
It is suspiciously easy, but do you understand it?
Yeah.
So here's 5, 9. And you're right, the slope is +1, so it's going to go like that, up 1 over 1.
Yeah.
By the way, this red line that slope should be probably steeper, because it's a slope of -5, which is steeper, a lot steeper than 1. So it's more like this.
Okay.
But that's your equation. Now, I didn't have to do all that stuff. I didn't realize when you put this question up here, they didn't want you to graph it, but it's okay. It's good practice, right? To graph it. So, but what this will help us do is it'll help us see, oh, what do I plug this into? The red, the yellow, or the green? What do I plug -10 into?
-10, you could plug it in for the first equation.
Yeah, it's going to be the red one, right? How about -1?
-1. You could also plug that in for the first, or no, not the first equation.
Not you could, you have to plug it into which one?
The middle one.
The yellow one. And how about 5? Where does 5 get plugged in for?
Can go into the last one.
It has to go into the last one.
Yeah.
Why can't it go into the other one?
Because the other one is not less than or equal to. It's just
that's correct. And 8 would also go into the green one.
Yeah.
Okay. So what is h of? So let's just do this. What is h of -10? Well, you do -5 times -10 minus 15, which is +50 minus 15, which is 35.
Nice.
Make sense?
Yeah.
The yellow one's easy. What's the yellow one always going to equal?
5.
Yeah, it's always going to equal 5. Just look at the graph and you can see it. How about the green one? What's the green one going to equal? 5 plus 4 is 9. And 8 plus 4 is?
You're going to get 12.
Done.
Nice.
And that is how that works.
Easy enough. Oops. Okay.
You got time probably for another one. You got another question for me, or is that it?
Let me find another one. Oh, this one looks good. Fx equals 2x minus 9 gx. Okay.
I'll color code them. Okay. So f of g of x, you get the hang of what I'm doing? F of g of x equals, so I'm going to start with f of x. Instead of writing the x, I'm going to write a big old parentheses, and then I'm going to go back and backfill in those parentheses with the red function, which is g of x. I'm going to plug it in there. Make sense?
Yeah.
So this equals 2x plus 6 minus 9, which is just 2x minus 3. Done. Let me see you try the other one underneath it.
Okay. So the other one is g f of x. So you gotta get g, which is f plus 3. Then you throw the 2x minus 9 into there. And then you get 2x minus 9 plus 3. And then that's 2x minus 6. All right? Yes.
That is correct. Good.
Sounds good.
Good. You get how function composition works? And
Yeah.
one last question I'll ask you. How does functional composition relate to inverses? Do you remember?
No.
So here's how inverses, you've learned inverses, right?
Yeah.
Okay, so here's how inverses and functional composition works. If I have f of x equals, I don't know, let's say 3x plus 4, and if I want to find the inverse of it, let's say g of x, if I want to know if g of x is the inverse of it, the way I can tell if it's the inverse is if when I do functional composition, like I just did, like you just did with f and g, these are not inverses of each other. Because if they were inverses, your answers for both of them would simply be x.
Yeah.
That's how it relates. So, and by the way you find an inverse is you flip the x and the y. So I'm going to first find the inverse, and then I'm going to prove to you that it is in fact the inverse. So I'm going to flip these, the x and the y here. So x equals 3y plus 4. So x minus 4 equals 3y. So y equals x minus 4 divided by 3. That is your inverse function. X minus 4 divided by 3 is the inverse of 3x plus 4. Okay, now I'm going to erase all this as if I'm just asking you this question. Are these inverses of each other? So how do you prove that they're inverses of each other? Well, one way you can prove it is by plugging in f of g of x and then plugging in g of f of x and making sure they both turn into, at the end, x. That would mean that they're inverses. So let's see how that works. So this is 3 times that plus 4. I'm going to plug in the red, x minus 4 over 3. Notice what happens. What happens to the 3's here?
They cancel.
The 3's cancel. And you get,
so do the
bye-bye.
4s too.
You get x minus 4 plus 4. Oh, hey, that equals x. How nice. How nice. Now we're not done. We have to also check this one. So I'm going to plug in the blue function in for that red function, 3x plus 4. And what do you know? The 4's cancel. You get 3x over 3. And the 3's cancel and you get x.
Yes.
So these two functions, f of x and g of x, written here, are in fact inverses of each other.
All right.
Okay?
Cool.
All right. That's it. Good job, as always. Come back for more if anyone out there is watching this video in YouTube land.
Like and subscribe.
Like and subscribe, or get your own session. You can do so at 204tutor.com. Bye-bye for now.